Nuclear decay is the process by which the nucleus of an unstable atom loses its energy by emitting radiation, including alpha particles, beta particles, and gamma rays. Materials that spontaneously emit such things are known as radioactive. Alpha decay is nuclear decay that results in the emittance of an alpha particle. An alpha particle weighs 6.64 times 10 to the negative 27 kilogram and is composed of 2 neutrons and 2 protons. It is identical to a helium nucleus. Alpha decay only occurs in elements that are heavier than 106 unified atomic mass units and can result in the emittance of gamma radiation. The alpha particle has a charge of 3.2 times 10 to the negative 19 coulombs and travels at 14,989,622.9 meters per second, or roughly 5% the speed of light. Alpha particles have a very low penetrating power and can be absorbed by thin sheets of paper. They can also travel at only a few centimeters through the air due to molecular collisions. Alpha radiation is highly ionizing because it has a very high energy. It also has medical applications in the form of gastrointestinal metastatic cancer treatment. Its low penetrating power and high ionizing ability allow for treatment with little collateral damage. Some alpha particle emitters are also used in smoke detectors. A current is passed through an ionized gap of air, and when smoke particles interfere with that current, they can trigger an alarm. Alpha decay also accounts for 99% of atmospheric helium as a result of heavy elements exposed during mining. Alpha radiation's high ionizing power makes it much more dangerous. It can cause roughly 1,000 times more chromosomal damage if inhaled than beta or gamma radiation.
There are two types of beta decay, beta plus decay and beta minus decay. Beta plus decay is a positron emission, while beta minus decay is an electron emission. Both have a weight of 9.11 times 10 to the power negative 31 kilograms. The charge on a beta plus decay particle is 1.6 times 10 to the power negative 19 coulombs. The beta minus decay particle has the same charge but is negative. The speed of both is 1.3 times 10 to the power 8 meters per second, about 44% the speed of light. But why does beta decay occur? Beta decay occurs as a result of excess neutrons in the atomic nucleus. Basically, the excess neutrons make the nuclei unstable. Beta decay converts these neutrons into protons to bring stability to the nuclei. Two cases occur: beta plus decay with the emission of a positron and an antineutron, or beta minus decay with the emission of an electron with a neutrino. Beta particles travel faster than alpha particles and carry less charge, 1 electron compared to the 2 protons of an alpha particle, and so interact less readily with the atoms and new molecules of the material through which they pass. Beta particles can be stopped by a few millimeters of aluminum. Medical applications of beta particles include positron emission tomography, PET, medical imaging as it's most commonly known as. It is used widely in the field of oncology, so it's important in cancer diagnosis, follow-up evaluation, and radiation therapy planning. Another use of beta particles is beta-emitting radiopharmaceuticals. For example, carbon-14, iodine-131, oxygen-15. So these are used mainly for medical imaging. Beta particles can also be used to treat health conditions such as eye and bone cancer through radiation therapy. One very important use of beta particles is in carbon dating. So researchers can measure the amount of beta radiation given off by carbon-14 nuclei to measure the age of very old objects. Beta particles commonly occur during nutrient-rich fission byproducts produced in nuclear reactors. Also, you might see radio particles every day. You're exposed to it every day because radioactive materials surround us. For example, it's in our food, in the soil, and in machines. So watch out.
Gamma rays have no mass and are composed entirely of high-energy photons. Gamma rays are produced during gamma decay, which usually occurs after another type of radioactive decay. Most gamma rays travel at the speed of light because they are composed of photons. Gamma rays have no mass and therefore no electrical charge associated with them. Gamma radiation is one of the most penetrative forms of radiation and loses roughly half of its energy through 500 feet of air. Because they are merely highly energetic waves, they are poor at ionizing atoms. Many centimeters of lead or multiple meters of concrete are required to absorb high-level gamma rays. Gamma rays have wavelengths shorter than the diameter of an atom, or less than 10 picometers. Gamma rays have been used to destroy metastatic tissues and also have applications in medical imaging. X-ray imaging has made gamma radiation one of the most well-known forms of radiation in popular culture. They usually have an energy of above 100 kilo-electron volts. Gamma radiation can also be used to sterilize food and medical equipment. Gamma radiation can be found globally in the form of background radiation. It can be especially high during terrestrial lightning storms.